Binary in-order traversal. Given the root of a binary tree, return the in-order traversal of its nodes as value. We're doing this in JavaScript. We're going to cover recursion and call stack. We seldom deal with binary trees in JavaScript, but we do often deal with recursion in JavaScript. I put this console.log statement in here for a purpose of understanding what they want from their question, what they didn't ask. Given the root of a binary tree, return the in-order traversal of its nodes as value. What they mean is they want to go in order. They want to go left, root, right. Left is null, so there's nothing to traverse. We go right. Right has a left, so it would be 3. And then we would have, it would be 1. First would be the root. Left side has nothing. We have the root. And then we go right, and we go 3, and then 2. That's what they want. This, we can extrapolate a meaning from. What they mean is root is value is 1, left is null, right is 2, and then left of right is 3. That's a little bit hard to figure out. It's not so intuitive. This makes a little more sense, and it corresponds to the constraints where they say the node.value is between -100 and 100. Okay. So what we want is we want to figure out what they're asking. So that's why this console.log statement was helpful to stringify the root. So we could see that it has a value property, a val property, a left property, and a right property. And the right property has the value of an object, which corresponds to the initial root. So we're not getting an array here. We're getting an object which has a left and a right property. And create a second parameter for storing or accumulating a result. It's initialized to an empty array. And we can get rid of this. That's only for understanding the problem, which they didn't explain very well with this example. And we start out, we say if we don't have a root, return an empty array. Next, we check to see if we have a root.left. And if we do, we're going to add that onto the call stack. We have a call stack of 1 right now. We've called this function. Now we're going to call it again on root.left, but we don't have one, so we're going to skip over that. Okay, so we skip that, and now we push on root.val. Root.val is 1, so that gets added. Now we're going to the next one, root.right and in-order traversal root.right. Yes, we have a root.right. It's an object. We're going to traverse that object with passing in root.right. Root.right is this node right here. That's root.right. We pushed on 1. Our array now has a value of 1, and it's 0th index. So we pass that on. We're passing that into in-order traversal. Now the call stack is going to be 2. Root is now 2, this node, in this second call, in this call stack of 2. We're going to check to see if it has a root.left. It does. And we're going to traverse that root.left, passing in our array. Remember, index as 0 is 1. So we're going to pass that in. Okay, so now the call stack is 3. We're going to check to see if 3, our new root here, has a left property. It doesn't, so we're going to add on 3. Now we're going to check to see if it has a right. It doesn't, so we're going to skip over that. Okay, but now we have to pop 1 off the call stack, and now we're in call stack 2, back up 1. Okay, now we have to push on. We have to see if root has we did root.left for this one. Now we have to do root.right for this one because we skip over that. We're going to first push on root.right, which is 2, and then we're going to traverse root.right. Do we have root.right? No, we don't. So we push on 2. And then we're going to do an in-order traversal of root.right. We don't have one, so we don't have a root.right on this. So we're going to push on 2. And then we're going to return our result. And we're all done. So our end result is going to be 1, 3, 2. Right, and we're just going to push on that value. We're not going to push on the node itself.